Hey, people. Just pulling up the lecture. Give me a sec. All right. How is everyone? Okay. More or less. Some people are more okay given the outcome of the test. Other people are less, whatever. So I'll talk about the test. We'll go through it a little bit, but we'll introduce some new subjects too, and move forward. And as I go through the test, I'll minimize you guys and put on the chat box. So if you have questions, feel free to throw them in the chat box. As I go through the test, this is stuff I'm going to be introducing gradually throughout this block. In the second block, I'm going to be introducing all these statistics. I know the first lab was posted on the Canvas page, and the way you'll start running these statistics, I'm showing you some of the outputs, not how to run them today, we'll get to that, but the actual outputs themselves. So this is our test. The mean was a 77. And the standard deviation was a 13.5. So 77 plus or minus 13.5%. That was the spread. That was the distribution that we had. And the 95% confidence interval, we're going to talk more about that. The median was also 77. There was no way to get a 77, but right in the middle, there was a 76 and a 78. And so split the difference, 77 is our median. And the skewness and kurtosis, you see skewness is barely positive, kurtosis is barely negative. You want those pretty close to zero to show a good distribution. And this is this is what it looks like for everybody. I color coded it. So the yellow, those are the A's. There was 106%. That was the top. And so we had, these were A's, B's, C's, D's, F's, and every single semester, if you're down here, right? So if you're down in this territory on the first test, people do this every single time I teach, every class that I teach. And then the second time around, the second test, the third test, they're up in the A's. Part of it is learning the personality of my questions. As you meet someone for the first time, you don't know everything about them. As you meet a test for the first time, you don't quite know what to expect. What kind of adventure are we going on? I have no idea what to expect with this person. And is this a saint? Is this a demon? Who am I working with here? And then as you get to know people, you can predict their responses to things. You can predict their conversations. And it's the same thing with tests as you get to know a professor and the way of test taking. Now, this is the actual distribution that we have, where there's the frequency curve right here. What you want to see is a bell curve. Remember, I said there's barely a positive skew. That's what this is. That's 106%. Just barely positive skews it, meaning the tail moves to the right. But it's a pretty nice bell curve. It means we can run some analyses on it. We meet some of these assumptions. The statistics are going to be a little bit more reliable, a little bit prettier, and the quantile, the QQ, these quantile. Like what we're doing here, remember when I talked about quintiles and quartiles? If it's a vegetarian / meat eater study, they look at the top quintile, meaning the top fifth, compared to the bottom quintile, the bottom fifth. These quantiles, that's all we're looking at here. And it says if you track the line, expected versus observed, you can run some stats with some reliability, you have a decent distribution. And we'll talk more about this soon. But we all know what this means to some degree. The median splits groups into even halves, right? So our median was 77. There's just as many people who got over 77 as there were people who got under 77, right? That's a quantile. A percentile is just 100. quantiles, right? So we have quintiles and quartiles and the median, and just putting people into even groups. That's what this QQ plot, that's what it's doing. Now, bivariate correlations, this is a really early statistic to run when you're doing your own analyses. You're going to have to run all of these stats. You don't have to Photoshop and color code everything, but you're going to run all of these stats as you figure out your project and move forward with it. And what better way to introduce you to these stats than running them for our first exam? So I put in a few extra things: male versus female, number of page views on Canvas, duration spent on Canvas. Now that may be a slightly weird statistic if people log in and then it's just in overnight when they go to sleep, right? But hours spent on Canvas, number of page views on Canvas, and I put in your entering GPA when you're entering this semester. So your Pacific only GPA. Now, I will never make this available to anybody else. Don't worry, this is as anonymous as it gets. This is just me running statistics and trying to figure out what predicts a good exam score and what advice that I can give to people and how we can escort people along to A's, because I want every single person to end the semester with an A. I don't do the curve thing. I try to get a bell curve in the way that I do tests, but I want everybody to beat the system and get an A. I'm not going to, well, it was all A's this semester, let's drag some grades down. I will never do that. I want every single student to get an A. I'm just not going to make it easy. Grade inflation is the worst. The victim of grade inflation is the student. It's setting you up for lazy behaviors and to think that the world will be forgiving when the world grades harder than Chem 25 and 27 combined. Chem 25 and 27 are so much easier than careers and life, right? Life grades way harder than I do, and it grades harder than bio. 51 and 61. So you would be the victim if I did grade inflation. Professors who do that, who are trying to curry favor with the students and get good feedback, these are really terrible, selfish people. And someday, it took me a while to learn that. The hardest professors I had, I was like mad at them. And then they're the ones who got me into my PhD and got me a job and stuff. Difficulty matters. But entering GPA, we've seen this bivariate correlation, right? Bivariable, two variables, bivariate correlation. We've talked about correlations and what those mean. A correlation of 1 is 100% perfect. I mean, this is the high school algebra stuff, right? You're just drawing a line, y equals mx plus b, draw the line, the slope stuff. You never see a correlation of 1 in inferential statistics, but a 0.5 with a p-value of 0.005. Now, we're going to start getting into the p-value this week, but what this really means is if the null hypothesis is true, meaning your GPA has nothing to do with exam 1 grade, that's a null hypothesis. These variables, there's nothing going on here. Null hypothesis. If the null hypothesis were true, GPA and your exam grade have nothing to do with each other, there is a 0.5% chance that you would have observed a correlation, we would have observed a correlation this strong or stronger of this magnitude or something greater than that. So we're 99.5% sure that something this strong or stronger is not the result of sort of spurious correlations, random scatter. But not everybody has a GPA. We have transfer students, we have freshmen, so this cuts it down to 30. Compared to 42 people who took the test, but that's the strong one. I put in alphabet number, as you go through the alphabet, 1, 2, 3, 4, 5, does your last name start with an A, B, C, D, E? And we expect to find no significance. That shouldn't matter. You're 989, we expect to find no significance. That shouldn't matter. Sex, we really found no significance. Men and women did the exact same. And page views and duration didn't find significance, but this is a p-value of 0.12. We're starting to get a little bit close there, so it's reasonable to explore further, which I'll show you in a minute. Now, this is a t-test. This is an independent samples t-test. Let's take men and women and let's look at the difference between them. We have two different groups, right? And so we see 23 males, 19 females, and these are the average grades. Both of them, it's a 77, give or take. Guys had a slightly narrower standard deviation, the average deviation, the variance, the scatter is a little bit, I'll tell you how to calculate standard deviation later. I'm not going to make you do it, but the standard deviation is a little bit narrower in the guys, but everyone got 77, I mean, give or take, like it's at a 0.5% difference. So males, females, we see the significance here is 0.926. This gets a little bit tricky over here in the bivariate correlation table. Sex, exam score, significance 0.926. Independent samples, t-test, we're seeing a 0.926. Now you'll see a significance of 0.131 right here. This is Levine's test. It's looking for this quality called homoscedasticity, which is the equality of variances in these samples. Are the variances of these subsamples of these populations that we're drawing from, are these similar? Are we comparing one curve to a curve that looks nothing like that, right? And so what you want to see is comparing sort of equal variances. The distributions look similar, and we meet that assumption. If this were less than 0.05, that's usually the cutoff that people would cut it, then we would have a problem with homoscedasticity. I heard a mic unmute. Does somebody have a question? Okay, so just keep yourself muted, and if you have a question, unmute yourself or type in the box or whatever. But we see there's no difference between males and females. And this is getting into linear regressions. This is a simple linear regression. It's really similar to those bivariate correlations, except this gives you more information. If you remember that bivariate correlation entering GPA, remember there's only 30 as opposed to 42, so we're cutting our sample down, but that p-value of 0.005. When we get into the linear regression, a p-value of 0.005, right? So we're taking sort of the same approach here. It's almost the same thing as this correlation. We just get more information. The R-squared tells us how much of the scatter, how much of the variance in the dependent variable, right? The dependent variable's exam 1 score. What did people get? Did you get 50, 60, 70, 80, 90, 106? What did you get on the exam? It's all over the place. It's scattered. There's variance, right? We didn't all get the exact same score on it. There's variance. And so how much of that variance can we explain with our collection of predictors? In this case, we have collected one predictor. That's why it's a simple linear regression. There's one independent variable, and that's entering GPA. Now, if you look at the degrees of freedom, you see 29. That's because there's only 30 students. This would be 41 if we had all 42 students. But again, transfer students. There's people who don't have a Pacific GPA, and so they're not included in this model. I can only include people who have data. And so I analyze the people who have data. And what this says right here, how to read this, this output is, you're entering GPA for each additional point. Now, a point is a big increment. A point is you go from a GPA of 2.2 to 3.2, or you go from a GPA of 2 to 3 or 1.5 to 2.5. A point is a huge difference. But what you would see was that each additional point of GPA, you would expect a 15.7 percentage point increase in the exam score with a p-value of 0.005. Again, what that means, a percentage point in this case, it's percent because it's out of 100, but a percentage point is really important to know that that's what it's referencing is percentage points, not percent difference, but percentage points that would be added for each additional point of GPA. Now, this is stuff we're going to get into very soon. You're going to be running linear regressions. It's not that hard. Nathaniel is going to be helping walk you through it. I will be helping walk you through it step by step. I'll go over instructions. He'll go over instructions. It's not that difficult. Understanding context of when to run it, that's really the most difficult part. But reading it isn't really all that hard, right? You have your R-squared. The adjusted R-squared is just, I'll talk about that later, but if you're including in these terrible predictors that don't mean anything, you make adjustments to say, the R-squared is getting worse. Now this significance over here, we're talking whole model, but it's going to be the exact same because we only have one predictor. Now, the 95% confidence interval, this thing says for your entering GPA, for each additional point of GPA, right? If you're entering this class with a 3 compared to a 4, you would expect your exam score to go up at the population, not for this particular class, at the population level. Remember, inferential statistics. I mean, this is what we find in this exact class, but we're making inferences about a larger population. We are, in this case, 30 people. There are 30 people with a GPA, and the population of people who could have taken epidemiology but didn't, and who will in the future, that's who we're talking about, the larger population from which we have sampled. You all are a sample of a larger population, and in that larger population, this is the effect we would expect to see. We are 95% sure, because that's a 95% confidence interval, that in the true population value for each additional point of GPA would increase this exam score by somewhere between 5 and 26% percentage points. So that's reading a simple linear regression. Here's a multiple linear regression where we have two predictors. There are two independent variables. This is still a univariate analysis because there's one dependent variable. Univariate, one dependent variable. That dependent variable is still exam 1 score. And entering GPA and duration spent on Canvas. Now, I put both of these in the model at the same time. This is about as many variables as you can include in an analysis that only has 30 subjects. You start including more subjects and it gets a little bit too hairy. But here, what we're looking at, the beauty of regression is that you can hold things constant in statistical expressions, mathematical life, that you cannot hold constant in real life. So imagine something like height and weight. These move together. Height and weight move together. And height and weight might have different effects on cardiovascular health, right? Tall people, you have to pump that blood so much. For Shaquille O'Neal's heart, man, that thing is under a lot of strain. Heavier people, the higher your BMI gets, whatever. But you can hold one variable constant and statistically tinker with another. And that's what regression does so beautifully. That's what's so elegant about these models, is we now have a higher R squared, right? So 0.353, which says we're now explaining about 35% of the variance of the scatter in test outcomes. We're explaining about 35% of that scatter. And our overall significance has decreased a tiny bit, from 0.005 to 0.003, we now have two variables to consider, two independent variables. Univariate analysis, because exam 1 score, right? But we have two independent variables. One of them is entering GPA, which has gone up. What this means is if you hold duration constant, you do not allow that everybody stays the same and all you change is GPA. You change entering GPA, but engagement, however that's measured on Canvas, however long you're logged in, right? There's error here. And so there's an amount of inherent error in this measurement. There's error in GPA too. What classes have you taken? Are you all bio and chem, or have you been taking, I don't know what the easy classes are here, but you get the idea. Is it all, PE, or is it chemistry? And so GPA has error in it as well. It's not a perfect assessment. But if you hold duration constant with each additional point of GPA, you're now gaining almost 19 percentage points on the exam. And here's our 95% confidence interval, and our significance, 99.9%, right? So it's a 0.1% chance that if the null hypothesis were true, we would have observed something this strong or stronger. By chance alone. And holding GPA constant, now we have elicited just barely, according to the laws of significance, which we'll talk about, Ronald Fisher stuff, 1920s jazz age, we'll get there very soon. But holding GPA constant, everybody who enters this class holds your GPA constant, and the only thing that changes, you spend more or less time on the website. With each additional hour, your exam score goes up by not much, right? A third of a percentage point. So if you spent 3 more hours, everybody's incoming GPA held constant. That's not a variable to worry about. We're managing that variable. If you hold GPA constant with each additional hour you spend on Canvas, if you spend 3 hours on Canvas, you get an additional percentage point, and the 95% confidence interval is a little bit wide. Now, these are the statistics we're going to start to cover in more detail as we go. What's the difference between percentage points and percentage? Good question. So the percentage, if it's like out of 200 points or something, and a percentage point is going to, well, I promise I'll show examples of what this means, because it sounds sort of confusing, but a percent increase could be a larger number of points. It could be a larger, I got 3% faster in my sprint. How many miles per hour is that? I don't know. It depends how fast you were to begin with. So that's a relative comparison. And linear regression is very absolute in its prediction. Now there's a margin of error, and we're going to talk about that margin of error. But percent is relative. What is the percent of your VO2 max, or your maximum heart rate that you're training at? Let's say you can bench press 200 pounds, and what percent of that are you exercising at? Well, my bench went up 10%. Oh, I don't know how many pounds that is, right? But if it goes up, for an exam, like percentage points, it's a harder, non-relative, it's an absolute assessment. And I realize that I'm explaining it badly and it still sounds confusing, and it's a good question, and I'll come back to it. I'll show you some examples of where things go awry, and people always get this wrong. In the literature publications, I'm a peer reviewer for a few journals, but one of them, the Journal of Strength and Conditioning Research, I'm one of the gatekeepers of whether articles get published. There are lots of gatekeepers. I'm not like the only guy, but I'm one of them, and I'm always correcting people. I'm always correcting people's submissions on percent and percentage points. Now, I always do this. I ask the students. This isn't just a student. Study strategies. This is a student. This is the students with A's. The students who got 90% or better, I sent emails to all of them and asked for feedback on what did you do. Now, my advice isn't going to be all that helpful, right? It's been a while certainly since I was an undergrad, and my study strategies are going to be so different. My approach to intellectual endeavors and scholastic activity is going to be so different. I'm not taking tests anymore. I'm writing manuscripts and stuff. There's a very different approach that I have. I'm years removed from how do we study and how is it effective. I can read the literature and I can give you those summaries, but how students are succeeding in my class, the students are the authorities, right? The students who succeeded, what did you do? And if you can model yourself after them, it's a really good start. They'll be a better authority than I am. So I don't want to name anybody, but I highlighted a few points that I thought were really nice. And the whole thing is nice. What everybody wrote was nice and useful. But my favorite way to study is literally just reread, or just to read my notes back to myself until I know them by heart. This has especially helped me in the era of open note exams, as by the end of the process, I know my notes inside and out, and which pages certain topics are on. 21st century, one of the most useful things to know is where information is stored. Where's the website? Where's the resource? Where can I find this in my hard drive? Do I have file directories? Knowing where to access information. Oh, where do I keep this? That's just as valuable as knowing the information itself, to some degree. Now, if you're a clinician and you're working with a patient, you don't get to go, oh, hold on, let me Google it. You don't get to have that time. Or to pull out your notes, you're going to look incompetent. If you're the physician, you're going to do a surgery and you pull out the medical book and like, okay, where do I make the insertion, the incision, right? You're not going to look like a competent physician. But for most contexts of life, many contexts, if not most, many contexts of life, that's really helpful. It's a really helpful thing. And rereading your notes is a way of ingesting that material over and over until your body expects it. So this is another one where people will watch I don't know how to do lectures at double speed, whatever, but there was a time where I was going through 4 to 5 Audible books a week, and I would do it at double or triple speed. And it's a skill. You can do it. It takes time. Listening to things and retaining is different from reading and retaining. Totally different skills. Baseball and basketball, not the same sport. Just ask Michael Jordan, right? These are not the same sport. You can be really talented at one and horrible at another. And so reading and listening, 2 totally different skills. And this student said, it's practice, right, to do this, to listen to lectures at time and a half speed. Plus I sometimes talk kind of fast. And so, but I have gotten used to this too in terms of audiobooks. And so you can do in one day, you can get through Moby Dick. Just listen at triple speed. And if you've taught yourself how to do that, if you're taking an English lit class and you need to read Moby Dick or something, you can bang that out in like 6 hours, the entire book. We are very effective at listening, much more than writing. We have been speaking, a verbal species, for as long as we've had throats. We haven't been a written species for all that long, so we actually all read really slow, but we can train ourselves to listen faster. And so if that's something you want to do to be efficient, go for it. And but reviewing stuff, right? If you miss it, review it again, and if you miss something, revise your notes, add to it. This one, I highlighted a few things. I almost always handwrite my notes. It gets embedded in my memory more. Tons of studies say that. That is very consistent with the literature, and so what the student is doing is employing science. I mean, this really works a lot better. And I use different color pens to indicate the more emphasized points, also effective. Dan Brown, I'm sure a lot of you know who he is. He's the guy who wrote Da Vinci Code. But the guy sold 200 million books, and he color codes everything. I mean, I think it's font when he's typing and stuff, but the effectiveness, he gives so much credit to his color coding and in the process of his novel creation, and it works. If that works for you, do it. I think what was most helpful was writing some of the examples of topics that you had discussed in class. I learned better with a certain memory attached to a topic, so writing down specific examples gave me a better idea of what the topic was, rather than just simple definition. One of the most critical points anyone can make. There are books written about this. The Foer brothers, I mentioned this at some point in this semester, either this class or the other one. There's 3 Foer brothers, F-O-E-R. There's not 4, like the number 4 is 3 of these brothers, and they're all these sort of literary royalty. And one of them, his first book, was called Moonwalking with Einstein. And he went, I think it was 2006, he went and won the US Memory Championship. And in the book, he explains, I'm the guy who walks into a room and I have no idea what I'm doing in there. Was I getting something to eat? Did I leave my wallet in here? He can never find his keys. He's that guy. He doesn't know what the hell he's doing in life, right? He can't remember from one moment to the next what his last thought was. And then he goes and he wins the annual memory championship. You know, they'll show you a deck of cards. You memorize the order of the cards. There's 52 or whatever cards in here. And then they'll shuffle them and say, put them back in the same order. I mean, you can get like 2 cards in and you're done. And I mean, so it's the how many digits of pi can you memorize types of activities. And this guy was the best in the US. And what he did was exactly this, right? You visualize stuff. You come up with analogies and contexts, and it's very specific contexts and employment of visualization for these memory tricks, but nobody's memorizing a billion digits of pi by kind of rote memorization of the numbers. That doesn't work. Context. That's why I give so many analogies and visuals for things, is because people learn that way. The students who have graduated 3-4 years ago and are coming back saying the only thing they remember is all the visuals, and that was the coat hanger on which they hung everything. The people who tried to memorize vocabulary for the sake of vocabulary forget that vocabulary, and they don't go forward in life any smarter. Right? Analogies, visuals, contexts, probably the single most important thing you can do at the onset of learning and at the outset of learning as well. These are 3 different people, color-coded. The first one, listen to the lectures again, right? The second one, near to the exam, I re-listened to the lectures that were more content-heavy for the refresher. Third person, re-listening to the lectures and rewriting notes. So there's a theme with these 3, which is why I lumped them together, of re-listen, use the resources that are available to you. And I know a lot of people who didn't score as highly as they'd like did that too. A lot of people are doing that, but those resources are available, and it is an effective way of re-confronting the material, becoming more familiar with it. This one I liked. It is apparently one of my quotations I don't remember saying, but it really sounds like something I would say, and so I'm sure I did. The smartest people are the most curious. And this goes back to those contexts and those analogies. These people, curious people, even if you get a C- in the class, which this person got an A. But even if you get a C minus in the class, Nathaniel said this a few lectures ago. At the very end, he chimed in and said, you know who the most successful students are that the professors love and will write the most glowing supernova of a letter of recommendation for, and these students end up 2 tax brackets higher, are the students who got like B's, but they were so curious and they learned the material so completely that they're creative. The last thing you want to do is just, again, that rote memorization where you just, all right, let me just memorize everything for the test, because you'll never accomplish anything in life that way. What you want to do is be creative, right? You want to be imaginative. If you go forward in life and the only thing you have is you're an automaton, you're a robot, and you can respond with, okay, now I'm programmed to do this. Nobody goes to bed at night hoping to wake up a robot tomorrow, incapable of creative thought, right? You want to be curious. You do not want to go through life incurious. You want to be creative, and that is the best way to come up with novel ideas to contribute to the world in ways that are not just, robotic. And then again, rewatching and adding more detail, making very accessible and organized notes. So that's the feedback from this. Now, that I have to qualify that statement of at the beginning, at the onset of learning, everybody has to do some memorization. There's vocabulary to learn, independent and dependent variables and cross-sectional studies and univariate and multivariate analysis. There's all this vocabulary and you have to memorize it, right? If you're going to learn a language, before you can do the poetry of the language, you have to master the prose. You have to master, and there's a couple of lectures at the end of the semester where I'm going to talk about use of language, because that's one of the most important things that you can do, is how you communicate science, how you communicate anything. But grammar, sentence construction, the cadence of what you're saying, where to place particular information, that's really critical. And so if you're going to learn a language, you have to memorize the grammar and you have to memorize all the tricks and strategies and vocabulary, and then you can get creative with it. So there is a part of memorization that's essential at the onset. Just remember Nathaniel's great at tutoring. Here's where we are so far in the semester. We've done one of these. So we're 100 points into a 500-point semester. We've done 20% of your points. If you started rough, who cares, right? Finish strong. There's 400 points to go. 400 points. The 80% of all of your points are left to go. That first exam, it stings. Get over it. If it stung, let's move forward and ace all the rest of them. Ace the labs. And most of the stuff is just take home, right? There's 3 exams that's the hard stuff. Everything else is take home. Here's 10 points. Log on to CITI, and do the certification. I shouldn't be saying this, but the way to do it is never pay for it, right? It might ask you to pay, but the university pays. There is a fee. You don't pay it. So if you're pulling out a debit card, you've done something wrong. You actually have to log in. I posted instructions on how to register in Canvas. You'll see it. It's in Canvas, how to register. Now, registering isn't all you have to do. You actually have to go do the CITI certification. The first time I ever did it, it took me like 20 hours because I read every module and took the test seriously. And then I realized after that first time that you can just go back and retake the quizzes. And they tell you the answers after you've taken them the first time, except for the very last one. The very last one you can't retake. Yeah, so most people will just go 100%, 100%, 100%, 100% all the way through, and then the last one 0% because they just clicked A. But there's usually about 5 questions, and anyway, so do the CITI certification. If you're going to do research, you have to be certified. And it's IRBs, institutional review boards. They mandate that you're certified before you do research, before you do any real research, human beings and rats and whatever. Yeah, if you're doing research by I'm at home reading an old textbook, that's not research, right? You're not doing some interventional thing. But if you're doing actual research, you have to be CITI certified. Now, the IRB forms, you have to fill these out too. And I have posted I took this picture this morning, and in the additional materials section, there's the CITI instructions. It's in there, you'll see it. There's the final poster project resources, and then there's the IRB forms. Click on that, you'll see this. This zip file has a bunch of stuff in it, and informed consent examples, stuff like that. You don't need all that. these two things are in it. Now, I download this if you want to move forward in research, but these are one of these two forms you will fill out. This is the assignment for the IRB. This takes longer than the CD cert if you do the CD cert like a efficient person. But the existing review form and interventional, where you're going to actually work with people, randomize and do experimental research, that kind of thing, depending on what you're going to do. If you're going to do epidemiology, it's existing data. If you're going to do ANOVA interventions, it would be this one. Most people are going to do this. Almost everybody in the class is going to do this, unless you plan on randomizing people in the age of COVID. I don't know how you would do that. And here's an example for each one. So active data collection. This is an example. This is not your study. This is an example of an approved document of active data collection of this one. This is an example. This is one of Mark Van Ness's studies. This is an example of de-identified existing data. So you would fill it out for your own study, looking at how these two did it. That's the IRB assignment. That's all you have to do. It's going to take time. Might take a few hours to do a real job on it. 10 points, take home. Everybody is in quarantine, so we all have plenty of time to do these things. Just make the most of your quarantine. Quarantine, everything in life should be an opportunity. Quarantine is too. Newton goes into quarantine from the plague and invents calculus. Right? Everybody should make the most of their quarantine experience. The sort of life's great accomplishers do so. Just whatever hindrance becomes an advantage. And so make sure you do the same thing. So we're here and we're going to get into the P word, significance, for a few lectures starting on Friday, and then epidemiological stuff, more of that. Lab 1, it says you can do it in main gym, but I don't think you can. I don't think it's open yet. I was a little bit hopeful that there would be isolated accessibility for students, either in the library or something, if there's spacing. But there's not. So but you can do this. It's just do it on your computer. Nathaniel posted instructions to have SPSS. That's way more convenient anyway. Running analyses from bed is so much better than doing them from the bunker. That terrible computer bunker in main gym. And then we're going to get on to prediction stuff. Lab 1 is going to be due October 9th, Lab 1. Lab 2 is about bias, and I'll start talking a little bit more, the QQ plots, stuff like that. And a bunch of regression information. Research topic is due, so October 14. That's actually kind of near to us. You're going to have picked out your research topic. Lab 2 is due October 16th, and then we'll have all of our review October 19th. October 21st, we have our second test, and it's on National Reptile Awareness Day. So I'm obstructing your big party celebrations, but exam 2, there's a lot of statistical stuff. If you will understand fully what I was talking about at the beginning of this lecture as we go into exam 2, how to read those outputs, how to get into those analyses and read those outputs. Now we have a recap sequence because these are slides from the previous section. As we move into our new section, there's going to be a little bit of overlap. We're going to take a couple of steps back as sort of a muscle spindle response to fire us forward if you're in 147 or have taken it, or if they talk about that in 129, you know what I'm saying. So kind of a stretch response where we're gonna go back a step before we go forward. Remember that PubMed, this is a great source for detecting all of these journal articles, detecting scholarly literature. And you're gonna, once you've narrowed your research question, you know what to look for. Now, I don't think anybody's gonna look for aerobic exercise on postmenopausal cholesterol, but you just type in stuff right here, and then you'll get all of your citations. You'll get your journal articles. And then as you read through those, ideally reading through a meta-analysis, you'll start to figure out the gaps in the literature. So getting into chapter 4, again, PubMed, you do your article search. There's a bunch of different kinds of articles. We've talked about this with the pyramid, right? The randomized controlled trials, people say is the gold standard. That's not really what gold standard means, but the idea that it's the best, right? This is the best. This is by which we compare all models to. Everything else is inferior to this one. And non-randomized trials, not quite as good. ideas and expert opinion and panel consensus, not really good at all. And so same thing as the pyramid, right? At the bottom, we have ideas and expert opinion and then bench science. This doesn't quite translate. You're working with rats and you're working with petri dishes and Bunsen burners and we're looking at mechanisms. And then epidemiology proper is in this area where we're not intervening with people. We're not experimenting with people, giving them placebos, stuff like that. We're just evaluating what exists, right? Is people smoke and people don't smoke. Let's see what's going on with them. Randomized controlled trials, either controlled or randomized controlled trials. Sometimes you can't really randomize all that effectively. And you're not always going to have placebo groups. If you're doing ice versus heat, hard to make that a placebo group. Oh, I got the placebo ice. It's sometimes hard to control these things quite as effectively as you'd like. So there are gradations here in terms of quality. And then the meta-analyses, systematic reviews. Meta-analyses are the best. They often contain a systematic review at the same time. Let's talk about the nature of findings and let's reanalyze everything. Now think of this as a sequence, right? Yeah, you begin with ideas and sort of move in this direction. You don't have to move between these two in that exact direction, but you tend to move in this direction. You always begin here, you always end here. This is always second to last. And the quality, make sure they're peer-reviewed journal articles, unless you're just saying, here's what people believe, here's what sort of consensus is, this is the state of belief and opinion on Facebook. Fine, you can consult opinion on Facebook. It's whatever, that's fine if you're talking about that, but you don't get to cite stuff like that and pretend it's science, right? You got to have peer-reviewed journal articles, and understanding that the experimental studies hold a little bit more weight than the descriptive studies, right? Those observational, correlational stuff where you're not actually intervening. So if I did the test and I said, all right, these students over here, we're going to randomize you. These students over here, you have tutoring and you have access to re-listen to the lectures. These students over here, you do not have access. And then we move forward and see how people do. That's experimental. I'm going to do ANOVA, release independent samples t-test if there's only 2 groups. So that's not epidemiology, that's an experiment. Those experiments are a little bit more sound than descriptive data. Again, meta-analyses, meta means after. A metastasis, like if something metastasizes, right? Metastases are after stasis, it's moving, right? After stasis, where we are spreading. And so meta means after. Meta anything means after. The way people use the word meta is almost gibberish all the time. Oh, that's my meta game. You mean after the game when you're discussing what your strategy was? What do you mean like meta? Like it's not middle. Meta sounds like middle, and that's what people are always talking about. That's not what it means. So usually when I encounter the word meta, it's like encountering the word significance. Not what it means. Now, reviews, these are really helpful if they're valid. The Cochrane Library, some of the most valid, if you can find the Cochrane study. This is assimilating all of this information, trying to eliminate as much bias as is possible by a human brain, eliminate that bias. And there's a bunch of different types of annual reviews, whether it's ACSM, NSCA, whatever organization you're in. These position statements and position stands often will come out with intervals. It might be as frequent as the Olympics, it might be every year. So this is an example of a position stand, ACSM, progression models and resistance training for healthy adults, right? That's a position stand. They take the summary of the literature. They all a bunch of famous names. I mean, if we go back and look at there's William Kramer, the most famous guy in the world on this subject. N. Travis, triplet Travis. This is a woman. I don't know what N stands for. It's hard to find. Once I figured out Nancy or something like that, but really famous researcher and author in resistance training physiology. It probably reveals the sexist state of evidence of the field that she's going by, Travis and Radamis. I mean, these people are huge names, world-renowned names. Same thing for just a different position stand for ACSM. Stephen Blair, this is a big meta-analysis guy. Now, when you go through PubMed, right? You see PubMed over here, pubmed.gov, right? You type in PubMed.anything and it tends to go there, but it's a government website. It's this database that contains an enormous bank of peer-reviewed, high-quality journals. They don't let the riffraff in, right? There are, I mean, this is an exclusive club to get into PubMed. And you can often find a full text link, but not always. Sometimes you'll find a full text link. You start by reading the abstract. You start by reading the title. Read the title. And if that has something to do with your project, now you read the abstract. It's a few hundred words. If that, oh, this is good, I think this is what I'm getting at right here, now you go try to find the full text link. Don't just find the full text link and start reading the full text and wasting a ton of time when you could just read the title and say, nah, that doesn't have anything to do with me. Or if it's iffy, right? If maybe, now you read the abstract and then you move on to the full text. You'll see stuff like this, the full text links. If you can get it, just download it, keep it, have it. You can reference it, and you have to cite it, and you can't plagiarize it, but you can reference it. If there are no full text links, you can sometimes find it through Pacific's library. They have redone the entire website, so navigating that website has another learning curve. The learning curve is less steep than the old one because the old website was so atrocious. The new one is much better, but it takes a new learning curve to navigate it. But just depending on what, like if it's this chocolate milk, a post-exercise recovery beverage for endurance sports, okay, maybe you want to know if there's funding by Nestle. And so you have to go find this full one to get to the very end to see limitations and conflicts of interest, and to know if some dairy or Mars or something, Nestle or whatever is funding this. Go get the full text link. You might have to do that through Pacific's library. You can do an interlibrary loan if Pacific doesn't have a subscription. Now, Pacific doesn't have many subscriptions. I am technically, apparently, I checked yesterday, still considered a student at University of Connecticut, which has a subscription to everything ever published. So something so close to everything they can just round up. And so I actually don't use Pacific to get my my articles and whatever references. I still just go through UConn. But Pacific they have some, and you can get everything, but it might take a week. You might have to go through interlibrary loan, and they'll get it for you. Pacific will get it for you, but it can take a week to receive it. So it's not immediate access. You don't just click it and have it. That's the advantage of some of these huge state schools. If you go to Ohio State or UConn or whatever, you're going to have these immediate 3-second click access to everything. With Pacific, it might take a week. Factor that into your timing signature of this. If it's due in 3 days, good luck getting that interlibrary loan in time. You bet you should have started earlier. Just like people who show up to something and like, man, the line is long, I'm never going to get there in time. Well, you should have shown up earlier, right? So this is on you. And so it's the same thing for when these projects are due. Now, Michelle Maloney, total sweetheart, super helpful. She's really smart in this domain. She's really eager to help. She knows what she's doing. She's available digitally, but she is the library for health, the librarian. She's not the library, but she's the librarian for health and exercise science. So she's essentially the library for us, the library incarnate. Now, the websites, right? Pacific's library page, the HESP library page at Pacific. Michelle, her, right? This is what she looks like. This is what, if you encounter her, this is, if you see her walking around campus when campus eventually stops being ghost town, this is her website. This is her email address. She's very useful. What you don't want to do, she's going to be slammed. We're all slammed. Pacific is understaffed. What you don't want to do is just ask her to do your work for you. What you want to do is figure out as much as you can, have very specific questions and say, all right, here's what I've done. Here's where I am. Here's what I have left to do, and I've hit a roadblock. She will unblock that road for you. So don't just everybody rush to her with emails, do my project for me. I mean, she will hate you, she'll hate me, she'll hate Pacific, she'll hate the universe, right? That's a totally unfair, irresponsible thing to do. Don't do that to her. But do use her. Do use her. She is so nice and giving and smart and helpful and ready to give you those resources. Just make sure you're not abusing her, which is what most people do these days, is sort of just abuse everybody. Now, there's a HESP 279 page. That's not this class, as you can see down here. But there is no 180 page, and HESP 279 is the graduate research methods page, which has all the same resources that we would have. So it's essentially the same thing. We don't need to have her make a page for us when this page already exists. And then there's one more website for all the other librarians and library domains if you want to do a little more exploring. This is the HESP 279 page you can see up there. That's the address for it. If you go, you'll see this stuff, some resources. Again, not 180, but it's the same stuff that would be posted for 180, so it's just as useful. And there's an online chat box where you can chat with her. She's not going to be there at 8 p.m., right? But during the business hours, particular times, she'll be there. Now, there are specific journals that are worth reading, specific journals that are worth downloading and skimming and ingesting and putting into circulation. This is in the book. It's a list. This is not a comprehensive list, not even close, but this is just in the book, page 55. Here's some stuff that they give. MSSE, Medicine, Science, and Sports and Exercise, one of my favorites. Now, it's published by ACSM, and I mean, notice this isn't an alphabetical list. M, E, J, R, I, J, A, B, J. This is not alphabetical. And they put this one on top because that's published by ACSM, and so is this book. This book is ACSM's Research Methods, and MSSE is the flagship journal of ACSM. They do publish a few. And if you publish with me, with Nathaniel and Lexi and our research group, this is where we publish, is MSSE. Wonderful journal. In physiology, there's some more: Journal of Applied Physiology, Journal of Physiology, Physiological Reviews, a ton of journals. That's just a few. This is just a glance at the playing field. This is just, you open your eyes for a quarter of a second and see some people. That's what this is. There's tons of these: nutrition, biomechanics, quality journals. This is from a different book. I believe this is a William Kramer physiology textbook, but here's a different list of types of journals that are reliable. One really great way of evaluating the quality of a journal is Thomson Reuters. Look at the impact factor. The impact factor is not assigned to fake journals. Fake journals, which I'll talk about in a minute. This is not Donald Trump saying fake news, because it's inconsistent with what he believes or his identity or whatever. But fake journals are a real thing, and I'm going to show you a ton. I'm going to scroll through really rapidly because it's pointless to spend too much time on them. But fake journals don't get an impact factor, right? So this median impact factor, it's sort of a citation index. It's how impactful is a journal. And so you're going to get into stuff like New England Journal of Medicine, Lancet, Cell, Chess, Nature, Science, all of these massive journals have huge impact factors. That's sort of the value of these journals. Now, where do you go to find journals? Again, PubMed, right? Now, this book is 5 years old, and there's over 20 million references already when this book came out, when this book was being written, which is a little over 5 years ago. Tons of different journals that are in there, these biomedical journals, tons of these things. And these are legitimate journals, peer-reviewed, indexed, valid. If you go to Google, Google Scholar even, you are not getting the scrutiny of the peer review process. You type this in and you just get whatever in the universe has ever been done before. So Google Scholar indexes essentially everything. Everything anyone has ever typed goes into Google Scholar. PubMed, Scopus, Web of Science, some of these other ones, I just always use PubMed, only publish in worthy journals. They do, just like music, every person who's ever lived now has a band. But what used to be advantageous about the major labels is they would do the scrutiny, quality selection for you. So you just had to show up and listen and buy what the major labels are putting out. It was a super corrupt business, which is why they all collapsed. But that's what the good parts of that are, what PubMed does. They tell you what's good. You don't have to filter through and look up the impact factor. You don't have to do these quality controls, because there are as many journals. You know, when your phone says scam likely and you don't answer that call, or you do, and they're asking for credit cards to pay off your medical debt. And you're like, I get one every day. It's about my car. I'm like, I don't own a car. And that's what these fake journals are. Now, Google people, even the real journals, there are articles about how Google is not a good index for this stuff because researchers are ranked by the number of citations they're accomplishing. And in Google, you can fudge that. You just make a website and cite yourself 1,000 times in that website, and then your Google index starts increasing. Anything that references your science, Google is giving you additional points, where more algorithms and systems that are more, that apply more scrutiny and are a little bit more valid than Google, like ResearchGate. So this is one of my papers, and it's 17 citations according to ResearchGate, 25 citations according to Google, and it also looks like they came out in different years. But this was the preprint digital, and this was the actual paper version that came out. But 17 citations versus 25 citations. What some of these will consider a citation is not the same thing as what Google, which is just sort of like, let's be inclusive and just count everything ever. Now, so Google Scholar, everyone types everything into Google, and it's just where everybody searches, but it's not that useful. I'll use Google from time to time looking for stuff. If I'm trying to be fast, if I'm just looking for something really quick, I'll use Google. If I'm looking for something sound, I use PubMed, and you should do the same thing. Now, you'll find there's overlap. It's not like everything on Google is bad and everything on PubMed is good. Google has the good and the bad. PubMed only has the good. Not that every published article in a valid journal is good. A lot of that is wrong. But the good journals, the peer-reviewed journals. Now, if you just type in something like this, bee pollen and supplementation, in PubMed, there are 26 results. In Google Scholar, there are 18,000 results. I do not think there have been 18,000 studies done on fluffy fresh bee pollen and its effect on cardiovascular health or metabolism or sleep or human performance or whatever. And yet Google has 18,000 results. There's probably 26 studies that are valid, and Google probably has all 26 of them, but it is just washed out with 18,000 other garbage entries that you have to filter through. Now, Google does a lot of the filtering and puts the most popular stuff on top. This is one of my favorite authors. This is Malcolm Gladwell, and this is one of his quotations. I've removed some of the ums and stuff, but Google gives you everything ranked by its popularity. This is the worst thing imaginable. You're trying to write an article that's about something new and fresh that people want to read. What does Google show you? All the things that people have been reading. It's set up to confirm the direction you're already on. This is the most brilliant take of Google I've ever heard. It's the least novel, most unimaginative, uninteresting way. It's just a way of being an uncreative person, is by relying on Google. Google tells you what the most popular thing is. Now you're believing that and saying that and pursuing that too. It's conformity is what Google is. If you want a real education, right, go to the library, go to a public library and go find what's on those shelves. Talk to the librarian. Maybe you'll get sick if you do that today, but if you want a real education, let's begin at PubMed. Let's begin with, is there a specific file that will help us get started on our projects? A lot of info now, so I'm finding it hard to know where to begin. I guess we need a question. Yeah, so begin with a question. That's a totally reasonable question to be asking. Google Scholar is a fine place to start, but that's not a good place to end. And Wikipedia is a wonderful place to start, not a wonderful place to end. PubMed is the best place to end. Maybe it's not the best place to start, but where you should end is the valid sources. And number one, come up with a really nice question. Really nice question. And just be cautious of typing that question in here, because what you're going to get is a bunch of sort of gibberish, right? Exercise advice, and there's 171 million bits of bad advice and 25 bits of good advice, thousands of bits of good advice, but among the 100 million. And be really careful and just avoid ask.com, avoid livestrong.com. These are almost always wrong more often than not. I mean, I don't know, a percentage of time they're filled with error, but the error rate is so outrageous. Don't even start there. Just avoid them. Assume what they're telling you is bad. I'm really bad if you ask me directions. If I'm your passenger, you say, do I go right or left? And I say left, you should go right, because I never get it right. I'm wrong more often than I'm right. And that's the equivalent of live strong and ask. Wikipedia is actually wonderful. Wikipedia is fantastic. Part of the reason it's fantastic is researchers go in there, physiologists, biomechanists, chemists, epidemiologists go in there and put their own research in because they want their research to have some sort of grounding, some footing, some fame, right? And if the common folk are now reading their research, that looks better, right? You're getting a little bit of esteem there. You have a broader audience. I've never done that with any of my research. I have gone in and messed up Wikipedia. I said that Gerald Ford was in the World Wrestling Federation, and he wrestled Coco Beware to a draw for a fundraiser for muscular dystrophy. I mean, that stayed up forever. I said a bunch of people died. I just put in like death dates of people who were living, and that stayed up for a long time. I put in a bunch of sort of historical people who I thought were historical badasses. I just put them all in the Knights Templar. I put Rosa Parks in the Knights Templar. She sounds like a badass. I'll put her in the Knights Templar, and that stayed up forever. And then as soon as I put up Daniel Radcliffe had an illegitimate child with Shania Twain, musician Shania Twain, and he was too young. It was like after the first Harry Potter, he was too young to rear a child. So Bobby McFerrin, the guy who sings the song "Don't Worry, Be Happy," is fathering the child. I put that story in on Shania Twain and Bobby McFerrin, and nobody cared. I put it on Daniel Radcliffe. Within 1 second, the Wikipedia audience said, "Oh no, that's false," and kicked me off of Wikipedia. Now you can still sort of do that today. Pros and cons. There are cons. Anyone can do it. But the world isn't populated by Courtneys who are just messing with stuff. The world is populated with people who take themselves seriously and put their own research and are very valid in Wikipedia. I have read physiological articles on Wikipedia that are better than the published studies because the published studies are old, and physiology is constantly changing, constantly evolving. Our understanding is mounting by the week, and Wikipedia is pretty current, and the researchers are the ones updating it. So Wikipedia is actually very good compared to things like what do MDs have? They have this software called Up to Date, and I think Wikipedia is better. I compared articles on both, right? As I was going through some of my own research, I got access to Up to Date, what physicians look at. That's what's on their computers. If a physician, if you're in the room and they're looking at the computer, they're not scrolling through Wikipedia, they're scrolling through Up to Date, and they should be scrolling through Wikipedia because I have found it to be better. It's just like free. Wikipedia is free, and physicians need to take themselves seriously. So there are a bunch of websites that are good. I would put Wikipedia on this list with caution. Never cite Wikipedia. Always go to their claims and read those citations, because people can do what I did and just say the whole world's in the Knights Templar. Now, fake journals, will somebody be my timer? As I'm 10 minutes, 5 minutes, whatever, just let me know. Fake journals, these, there's the number of ridiculous false findings and false 13 minutes, thanks, journals probably outnumber the valid ones at this point. So it's not just a Donald Trumpian fake news. Like this sounds real. Journal of Astrophysics and Aerospace Technology. That sounds legit. It sounds with some oomph, some power in there. Discovering the total contents of the universe. You can go find this online, right? Modern scientists have been searching for clues of some type of extraterrestrial life. Okay, we're already, maybe, if this were written by, Stephen Hawking or something, I would think we're going in one particular direction here. However, ancient scriptures give very interesting and important information and details concerning the total contents of the whole universe that is given in mathematical language which has long been forgotten by the mankind. It becomes like crazy, insane stuff, deciphered the code, and there's all these insane diagrams that look like it's some bad conspiracy theory show on Netflix that had $100 budget. And this is published in the Journal of Astrophysics and Aerospace Technology. That's a fake journal. Now, this is where I'm going to start skipping through this stuff. I get solicitations. By the time we started this lecture and the time we finish this lecture, I bet I'll have 5 new solicitations from fake journals that sound almost real. Journal of Physical Fitness, Medicine, and Treatment in Sports. These sound like real journals, and they're soliciting me to submit. Dear Dr. Courtney D. Jensen, hope this email finds you in good health. We would like to inform you that you are 1 step away from publishing. Await your submission, Kelly Horton. Dear Dr. Courtney Jensen, this is from Lung, Pulmonary, and Respiratory Research Journal. We are pleased to inform you we are launching special issue on this thing that you know nothing about. Will you please submit? Dear Dr. Shannon McNeil to Courtney Jensen, right? This came in my inbox, and what the hell is the matter with these people? Journal of Addiction and Clinical Research, and then it feels an immense pleasure to announce that we are launching a new journal. Warm regards, right? Or with regards, Meredith Grey. Like, oh, please, right? That's a fictional character in Grey's Anatomy. This is so embarrassing that anyone falls for this stuff and tries to publish here. What they're trying to get is authors of real publications to submit to the fake publications because it validates a fake publication. Here's an author who publishes in real journals. Let's see if we can entice them and seduce them into our fake journal, and it'll make our journal look real. Now this one, Dear Dr. Name. I guess that's better than calling me Shannon McNeil, right? Dear Dr. Name, referring your previous research and just the trauma and acute care. Now there are journals that are so closely tied to this. The names are so close. Dear Dr. Researcher, we cordially invite you to be an editorial board member. I find myself having been appointed as board members of journals I've never heard of. I find it on the internet. What the hell is this crazy nonsense that I am on the board of? I have never communicated with these people. I've never heard of this journal. I think this journal is at best trash, at worst ruining the whole name of science, right? It is metastasizing kind of through culture, right? This is not a benign journal. And I find my name on the editorial board and I have to contact these people. We quarterly invite you to do this. So we are aware of your reputation of quality research and trustworthiness in the field that's related to whatever the hell this is. Hello, doctor. With much greetings and respect, I am William Rose, honored to contact you based on your expertise in multiple sclerosis. Guess what subject I've never once published in? MS. Dear Professor, start each day with a great smile. We are delighted to announce blah, blah, blah. Dear Dr. Courtney Jensen, your time is my preference to confer about our journal's concern. Please submit to the Research and Investigation in Sports Medicine. These things sound real. And sometimes Michelle Amaral and William Heron, these people, we have published together, and they found one of our publications, the use of coarsened exact matching to evaluate the treatment mode in rib fracture patients. Now, this is a methodological paper. This is not about physiology. This is about how to use statistics and the importance of this particular statistical model, Nine Men's Thinks. This is not the same thing as we're talking about physiology, and they're both wonderful statisticians. They're better than I am, and brilliant statisticians. So I brought them on board for this one. Like, look, I need you guys to let's get through this kind of complicated methodological paper. And then people like, oh, please submit it. That was a Dear Dr. C.D. Courtney D. on behalf of Austin Psychiatry. All this stuff is crazy, right? And it just goes and goes and goes. And it just keeps every single day. I get several of these things. Greetings from Prissy. Dear Doctor, space, comma, greetings from Prissy. Dear author, again, right now, my email address is dinging with invitations to publish. This is maybe a 0.5%. I get these every single day. As soon as you publish, as soon as you get involved in research, create a name for yourself in science and epidemiology and biology and whatever it is, physiology, human performance, athletics, anything, you are going to start encountering these. And it's just evidence that the world is not filled with accurate, sound, trustworthy, reliable information. Most information you encounter is false and hilarious and ridiculous. And it's not just Facebook and Instagram and Twitter and Livestrong and Ask.com. Those are obvious locations of hilariously inaccurate, incorrect information. Journals are also ridiculous sources of ridiculous information. They're what are called predatory journals. They're fishing for publications, and they'll just put me on their board, and I have to contact them and say, with some profanity, making sure I get off of there. And you never respond to these things, but you're going to start to get them. The most important part for today is to avoid them. Here's some websites of saying, do not read these journals, do not acknowledge these journals, never submit to these journals, close your eyes to them, pretend they're not there. They're all ludicrous, trying to scam people into false information, and mostly it is an economy, mostly out of your dollars, right? It costs money to submit to these journals. Now, some really high impact, valid journals cost money to submit. And so every single fake journal, though, costs money to submit to them. Okay, so chapter 4, some important considerations. We'll just go through this paragraph kind of sentence by sentence. Stay focused on the
Can I ask a quick
subtopic.
question real quick?
Yeah.
So we have that date to get the research question in.
Mm-hmm.
That entails coming up with a question and then also looking at the gaps, right?
Yeah, you're going to have to know some gaps to come up with a question. Now, your question can start to take a clearer shape. It can be a little bit blurry on day one. Now, if it's like, oh, I want to research baseball, I want to research health, I want to research whatever, that's a terrible question, right? If it's, I want to research the mechanics of pitching, fastball velocity, something like that. Okay, fine. There are some gaps in that literature, and we can talk about that, and you can figure that out on your own by reading. But as you move further along in your reading, your background reading, getting familiar with the data that exists, the clarity of your picture will sharpen. It doesn't have to be the same question you ask on the due date is not the exact same question that's on the top of your poster at the end of the semester. It's probably going to change. Does that answer your question?
Yeah, so basically by the due date, you want like a general question.
As specific as you can be. You know, again, it's not like I'm studying sports. Like, that's okay, let's start over from the beginning. What sports are we talking about? So be as specific as you can, but realize there's sharpening that is yet to happen as you move further in the literature. If you can find some gaps in the literature ahead of time, wonderful, really going to get you ahead. If you have a somewhat wide net at the beginning, somewhat, right? You're not just throwing in the tuna net into the ocean saying it's this ocean that I'm fishing in. Okay, it's this field of study that I'm going to try to extract a finding from. Okay, that's not helpful. But you will sharpen your research question as you move forward in the semester. So,
cool. Can I clarify one thing real quick? Sorry. We do the projects with existing data, right? Like nothing with like any.
You can do either way, but it's going to be tough to not use existing data in the time of COVID to go collect your own. People have collected their own in the past, but how do we submit a research question is another question in the chat box to me. Just send me the email, either on Canvas or my cjensen1@pacific.edu email address to submit me the research question. And you will have groups for this. Well, I promise we'll talk more about it, but I totally forgot what the question was that wasn't written. What was the question?
It was just about like, are we using existing data or are we having to do like
existing data is most likely going to be what you're doing. Now, I have some, and I'll show you where resources are on the internet where you can go find some. And so we can talk more about the data that's going to be available to you to use. Some of it just already exists and you can just find it on the internet, and I'll show you those links, I'll show you those resources. And then some of it, if you're getting involved in our lab group, our research group, then there's data available. And so we'll talk more about that. But so just don't get overwhelmed with larger questions, with the big picture stuff, when what you want to do is focus on your particular gap, your particular question. And again, just because a paper is published doesn't mean it explains everything or that it's even true. There are errors that you have to recognize. There are not just fake journals, but even the real stuff can get a little bit bogged down with error. And then finding a review paper is often the best thing you can do. And you could do that before the due date. If you have a research question, go find a Cochrane review or some ACSM position stand or some other journal's position statement and some meta-analysis on a subject. And and that's going to be the best thing. You may only need to read one thing, and they usually talk about the gaps. Now, again, meta-analyses, we're going to talk more about this and what PRISMA guidelines are. Systematic reviews, this is the top of the pyramid, right? It happens after everything else. They synthesize the work everyone else has done. And when you start, I mentioned this earlier, when you start your excavation, your search, and when you're doing all of your reconnaissance work, trying to dig up findings, read titles, just read titles. And then if that title looks good, go to the abstracts. And then if the abstracts look great, okay, then go get the actual paper. And then the context is critical. You can't know content. I said this at the beginning of today's lecture. Somebody had one of the students who got an A had made a comment about contexts and situations and visualizations and whatever it's analogies or situations. That if you don't know that information in the context, you can really never know content fully. So always know the context in which, 1 minute, thanks, in which your research, what you're pursuing. And new evidence is always going to be becoming available. So just as you move forward, do so with a sense of proportion about what you're reading right now. The very last point, I just want to, you can log off. I'm just going to make one point about this sort of old acquaintance of mine. I may have mentioned him at some point this semester, but this is just to give you an idea of how long it takes to develop expertise. So Ben Tollerine, he used to be a Pacific student. He ended up moving out to Texas to finish up his degree. This guy is smart. Ben Tollerine, this is a sharp guy. And we had these conversations, it was like 5 years ago. We were going back and forth for a while, and he makes millions of dollars a year playing poker. And he talks about the thing that offends him most in the world, the thing that upsets him, the thing that if anybody has a trigger sentence or content, whatever, it's assumed mastery, where people think they're good at things because they've done it for a week, or oh, I read a paper about that, or whatever it is. And Ben Tollerine, he doesn't tell people what he does for a living. You can look him up. You just find him online, right? And he'll talk about losing, $1 million in a hand and then making $2 million later that day or whatever. I mean, these are like single pot earnings that he's had. And every time somebody asks him, what do you do for a living? I mean, this guy is like a millionaire poker player. Every time someone asks him what he does for a living, he comes up with something. Just oh, I'm an architect, or oh, I work in public. I mean, he just comes up with something because he doesn't want to say, I play poker, because every single person he has ever said that to says, oh, I'm really good at poker. Or, my uncle's amazing at blackjack. Whatever. He's like, no, they're not. Every single person you've ever known is horrible at this. I take their money for a living, right? Ben can play tournaments without looking at his hand and win. I mean, he can go to Vegas and just beat everybody without looking at his hand. This guy, he is so smart, Ben Tollerine, not just about poker, but about strategy and life and philosophy. And what you want to avoid doing is believing that mastery and expertise and highly refined skills can be accomplished in a month or a year or even 5 years. As we move forward in research, we're not looking for expertise and mastery in this class. We're looking for some sort of passable understanding that has clarity connected to it and that doesn't have an ego, right? So that's what we're looking for. I'm not expecting you to have a PhD in your subject. I'm just expecting you to have footing, right? Have a little bit of footing on which you can grow and you can explain yourself clearly. All right, that's it for today. If there's anybody left, how many? Oh, there's still 28 people here. All right, good. Do you have any questions? Ricky, yeah, I have another class coming up right after this. I just saw Ricky's comment. I probably have a couple of minutes, but just call me if you have my number, and I can. Hold on, Ricky. I'm going to text you my number.
Thank you.
Yeah. Okay. All right. I will see everyone. Oops. All right. Ricky, did you get it?
Yeah, 971 area
Yeah,
code.
don't say it out loud because I don't want
No,
the
yeah, I
recording.
won't.
I don't want my number to be like if this. I just don't want my number to. But yeah, all right, you got it. Yeah, the second one, the first one had like additional numbers in it, but the second one. All
Yeah.
right.
Good.
Yeah, just give me a
All right.
call.
All right. Is there a time that works better for you?
Right now is fine. Yeah.
Oh, okay, got it. Bye.
All right.